In the depths of every iris lies a secret, a swirl of color shaped by mutations, migrations, and millennia of history. Scientists call it pigment. Poets call it the window to the soul. But what if the shade of your eyes is also a code, a living relic of where your ancestors walked, what climates they endured, and which genes they carried? Tonight we open that code and step into the dark mystery of eye colors and ancestry. Long ago, all humans shared one dominant trait: deep, protective brown eyes. In the intense sunlight of Africa, melanin in the iris shielded early people from harmful UV rays. This dark hue was an advantage, a natural defense passed from parent to child without much variation. It was the default of our species, the original lens through which our ancestors saw the world. Brown eyes still remain the most common on Earth today, present in billions of people across continents. They anchor a genetic memory stretching back hundreds of thousands of years. Even as other colors emerged, brown eyes continued to dominate because of their strong link to survival. In many ways, every lighter eye color is a variation carved out of this rich pigment. This base layer of humanity's gaze shows how environment drives evolution. When light levels are high, melanin rises. When UV is dangerous, pigment shields. Our earliest forebears didn't choose their color. Nature selected it for them. This is the foundation on which all other eye colors rest. Somewhere between 6,000 and 10,000 years ago, a single mutation appeared in a single human. It was a subtle switch in the genetic code near a gene called OCA2, reducing the production of melanin in the iris. For the first time, a pair of eyes looked not brown but blue, a spark of color against a dark-eyed world. That individual's descendants spread this trait far and wide. This was not just a random quirk, but a pivotal moment in human variation. With one change, an entirely new palette opened up, making eye color more diverse. In areas of lower sunlight, lighter eyes posed no disadvantage, so they survived, even thrived. Over generations, they became a marker of certain lineages. The story of that single mutation is a story of chance and geography. Without migration, the trait might have vanished. But humans moved, mingled, and carried blue eyes across lands, embedding them into the genetic fabric of Europe and beyond. Today, millions share that ancient link. Eye color isn't the product of a single gene, but a chorus of many working together. OCA2 and HERC2 on chromosome 15 take center stage, controlling pigment production and placement. Other genes act like background singers, adjusting shade, saturation, and patterns across the iris. The final hue is a blend of all these influences. Unlike hair or skin, eye color also depends on how light scatters through the iris's microscopic structures. Less pigment means more scattering, the same reason the sky looks blue. This optical trick creates the shimmering effect of lighter eyes. Genetics provides the paint, physics provides the shine. Even with modern science, predicting a child's eye color with perfect accuracy is tricky. Too many genes, too many interactions, and too much randomness shape the outcome. Each pair of eyes is therefore a unique signature, a biological fingerprint, unlike any other. All blue-eyed people alive today trace their color back to that original mutation. This means every blue iris is a living relic of one distant ancestor. Whether in Scandinavia, the Middle East, or North America, blue eyes carry the same genetic marker. A single thread weaves through countless family trees. This realization collapses boundaries. People who may think of themselves as unrelated share a silent connection in their gaze. The mutation was not isolated to a region, but to a lineage, spreading like a ripple through time. It's a striking reminder of our shared humanity. Blue eyes also became symbols of beauty and mystery in many cultures. Myths grew around them, painting them as rare or magical. But beneath the legend is simple biology, a dilution of pigment that tells a powerful ancestral story. Green eyes are rarer than blue and far rarer than brown. They form when moderate pigment combines with light scattering to create a greenish tint. In Europe, they cluster in places like Ireland, Iceland, and parts of Eastern Europe, but they can appear anywhere. Their rarity gives them an aura of uniqueness. Because green eyes result from a mix rather than a single mutation, they're harder to trace to one ancestor. They represent a complex interplay of genetic variants rather than a simple on-off switch. This makes green eyes a mosaic of history, a blend of multiple lineages. Cultures have long imbued green eyes with symbolism: envy, magic, luck, danger. Yet science sees them as a natural outcome of genetic diversity. Each green iris is like a painting where pigment and light meet in delicate balance. Gray eyes are among the rarest, often mistaken for blue, but with a silvery, steel-like hue. They may result from very low melanin and a high degree of light scattering in the iris stroma. This gives them a misty, almost otherworldly quality. Their genetic origins are still being unraveled. They seem to arise from combinations of alleles that dilute pigment even more than in blue eyes. Geography shows them scattered in pockets, parts of northern and eastern Europe, and occasionally elsewhere. Their rarity makes them a subject of fascination. In stories, gray eyes have been tied to mystery, wisdom, or power. But like all eye colors, they're a reflection of biology's experimentation, a rare note in humanity's visual spectrum. Hazel eyes shift between brown and green, sometimes showing flecks of gold. This effect comes from uneven pigment distribution, creating rings or gradients within the iris. Amber eyes carry a golden or coppery hue, even rarer than hazel. These colors defy simple inheritance charts. They result from multiple gene variants and subtle structural effects. In some cases, lighting can make hazel appear greener or browner, adding to their mystique. For ancestry, hazel and amber eyes tell a story of admixture and complexity. They're like living maps of multiple lineages converging, a testament to how humans have always moved and mingled. Brown eyes dominate in Africa, Asia, and much of the Americas. Lighter eyes are most common in northern and eastern Europe, where UV exposure is lower. This distribution reflects adaptation, migration, and genetic drift over thousands of years. Eye color can hint at ancestry but cannot define it. People with blue eyes can have diverse backgrounds, and brown-eyed populations can carry hidden recessive alleles for lighter shades. The map of eye color is a patchwork, not a simple gradient. Climate, isolation, and population bottlenecks all play roles in shaping regional frequencies. Understanding these factors helps scientists reconstruct human migration patterns. Sometimes one eye differs from the other, a condition called heterochromia. It can be complete, each eye a different color, or sectoral, part of an iris different. This can be inherited or caused by mosaicism, injury, or certain conditions. Heterochromia adds another layer of uniqueness to human eyes. Celebrities and animals alike display it, captivating observers with its striking contrast. In folklore, it often signified magic or duality. Science views it as a quirk of development, cells carrying slightly different genetic instructions. Yet it reminds us that even within one person, diversity can bloom. Many babies are born with blue or gray eyes that darken as melanin accumulates in the first years of life. This shift can surprise parents, but is a normal part of development. The final color often stabilizes by age 3. Even adults can experience subtle changes due to aging, hormones, or medical conditions. Although rare, pigment patterns can shift, making eyes appear lighter or darker over time. These changes show that eye color is not always static. It's a living trait influenced by genes, biology, and time. Throughout history, eye colors have been woven into myths. Blue eyes linked to gods or heroes, green to sorcery, brown to earth and loyalty. Cultures projected meaning onto hues, building stories that still echo today. These legends reveal more about human imagination than biology. They show how rare traits inspire wonder and fear. They also highlight how identity and appearance intertwine in society. Behind each myth stands the simple yet profound truth. Variation is natural, and every color has its place in the human story. While eye color can hint at ancestry, it's only one clue among many. DNA testing examines hundreds of thousands of markers, while eye color reflects a handful of genes. It's a sketch, not a photograph. Two brown-eyed parents can have a blue-eyed child if both carry recessive alleles. Likewise, a blue-eyed parent can pass on brown if the right combination appears. Predicting ancestry from eye color alone is unreliable, but taken together with other traits, it offers a glimpse of history, a visible thread connecting past and present. Geneticists continue to discover new variants affecting eye color. As sequencing becomes cheaper, more subtle differences emerge, patterns, rings, flecks explained by new alleles. The genetic map of the iris is still incomplete. Future research may reveal even deeper ties between eye color, health, and ancestry. Already, some studies link certain hues with slightly different risks for conditions or light sensitivity. The more we learn, the more complex the picture becomes, showing that a simple trait can hold profound stories. Step back and eye color diversity becomes a painting of humanity. Brown, blue, green, gray, hazel, amber, each hue a brushstroke of history. Each eye a testimony to adaptation, chance, and connection. No color is superior or inferior. Each is an expression of our species' creativity through evolution. Even the rarest shades are part of a continuum, not an exception. This palette reminds us that despite differences, we share one canvas, the human story written in pigment and light. As people move, marry, and mix, eye colors may shift in frequency again. Traits once rare could become common, others may fade. The human palette will keep evolving with each new generation. Our eyes are more than windows to the soul. They're windows to the past and the future. And every glance is a timeline stretching back to the dawn of our species. Knowing this can transform how we see ourselves and others, not as separate shades, but as chapters of one grand narrative. And so when you look in the mirror and meet your own gaze, remember, those colors are not random. They're echoes of ancient climates, migrations, and mutations. They're your ancestors staring back through time. If this story of hidden codes within your eyes inspired you, press like, share it with someone whose eyes fascinate you, and subscribe for more untold histories woven into everyday life. Every view, every comment helps this channel keep uncovering the secrets behind the familiar.